Okay, let's look at this problem. A system consists of a thin charged wire ring of radius r and a very long uniformly charged thread oriented around the axis of the ring. Just read this problem. The total charge of the ring is q, charge on the thread per unit length is lambda. Find the interaction force between ring and the thread. Okay, so there is the ring, that's the ring, and here is the thread. Thread extends from the center of the ring till infinity. It's huge. Okay, so you have to find, this force between this ring and this line charge. Okay, now you know that due to a line charge, see, there are two ways to solve this problem. First, you can consider field at a point on the axis due to the charge on the ring and take this length dx and then integrate it. So I will show you a simpler method. Only if you know this formula, right? So you know that field due to a conducting a wire, field due to a finite conducting wire. If you remember this formula, then only it's helpful. So if these angles are phi 1 and phi 2, then this Ey is equal to k lambda by r sin phi 1 plus sin phi 2, and this field here Ex equal to k lambda by r cos phi 2 minus cos phi 1. Or you can remember only this thing Ey. Okay, you can remember this thing only Ey, that will do. And you know, when you have a rod like this, a charged rod, the total field goes along this angle bisector. This is the direction of the field. Okay, so for the semi-infinite one, at a distance r, say at a distance capital R from it, this y component will be Ey will be equal to how much? K lambda by r sin, see this 90, right? Phi 1 is 90 and phi 2 is 0. So that's 1 plus 0. So that's k lambda by r, and obviously you know this x component will be same, k lambda by r, because the field will go through the bisector, right? This is very long, so this the subtended angle is 90 degrees, so it will make 45 degree. So this is 45 degrees, so Ey is equal to Ex. So Ex is this one, k lambda by r. So here the same thing I will use. It will have a y component here, and what matters is the x component here. So Ex is equal to k lambda by r. See, this distance is r. Okay, and so the force on the ring is this way. F is equal to, now this field k lambda by r multiplied by what was the total charge on the ring, q, right? So you put the value of k, 1 by 4 pi epsilon naught lambda by r multiplied by q.